Welcome to today's talk from Josh Batty and Mitchell Nordine of MindBuffer. And this is part of a series of talks that we're introducing this year, but then going into next year, from staff and guests, basically around contemporary practice in electroacoustic sound, in spatial sound, spatial music, contemporary performance. So from that spectrum all the way through to topics around acoustic design and urban soundscape studies, which covers the breadth of what we research and teach within the studios. Josh and Mitchell have been working together for a few years now. One of the most recent projects has been a performance up in Townsville. So hot not just in weather, but I'm sure in sound as well. And we asked them to come and talk about that today, which I'll touch on briefly, but also their collaboration as MindBuffer and some of the work they do within that. So welcome, and over to you two.
Great, thanks, Lawrence. I'm Josh, and this is Mitch.
I'm Mitch.
Yeah. We're gonna just talk about like the evolution of how we do what we do, and then at the end
where it began. How
we arrived to where we are, and then at the end we'll do a bit of a software show and tell of all the software we've been making, and then feel free to bombard us with any questions you guys have, and it should be fun. I'm a full-time staff member here as of 6 months ago. Finished my PhD last year, designing audiovisual granular synthesis instruments, and that was all great. And Mitch used to be a student here, and he was actually my first student when I started teaching 5 years ago. So RMIT has luckily brought us together. So forever in debt. So I'll just start and we'll get going. This is where I grew up. Leongatha, there's a lot of nothingness going on in this part of the world. I really, there wasn't much to do other than kind of play football or milk cows, neither of which I had any interest in at all. So I was kind of the odd one out. So in order to alleviate pure boredomness, I decided I was just going to play music nonstop. So from the age of 4, I picked up piano and trumpet and started doing that for about 3-4 hours a day up until I was a teenager. And here's a classic, really bad photo of me when I was 13 in the Sydney Olympic marching band. This is what I thought was real cool when I was in Leongatha, just playing music and playing trumpet all day, every day. And I was deluded enough to think I was going to be the next James Morrison. I kind of went about my business doing that, and similarly at the same time, this kid.
So I grew up in Townsville, which is not quite as barren as Leongatha, but So I started as an innocent violin player, and I got into DAWs and digital audio workstations when I broke my finger before an exam one time. I broke my finger before a violin exam, so I picked up guitar. My folks got me an effects pedal for the guitar, and it came with Cubase, like Cubase LE or something. Had maybe 2 tracks like that you could record at once. I was so excited, like I'd never come across anything like it before. Especially the reverb, it just totally blew my mind that you could just make your own music sound like it was in a church or something like that. So from this point I was pretty hooked, and I started out recording for friends and just basically recording all my friends' music because I had a lot of friends who are musicians as well. And then I traveled to Melbourne to study at RMIT for this. So I did the music industry course in order to sort of push that in that direction, like of recording, getting into producing records and that sort of thing. But literally the first group I recorded was like an Aussie hip hop band, and I'd never really been that interested in like the sort of style that they were going for. And I quickly realized that I was far more interested in exploring my own sort of compositions, but still using this sort of like digital platform, really just pushing it into newer exciting directions. And then I met Josh in computer sound class, and I showed him some of the stuff that I was working on, and he showed me some of the stuff he was working on, and we just decided to kick off a project together.
Get together over a bowl of tequila and see what happens. And it all worked out. I went to invited to the Academy of Performing Arts in Western Australia when I was pretty young, and left school early and went over and did a jazz degree over there, and then came back and finished did a jazz degree at Victorian College of the Arts. And life was going great, but then I turned 18 and started going to clubs and realised that there was far more people going to witness this type of music than they were going out to see my jazz gigs. Yep. So I'm like, maybe I'm not going to really be able to make a good enough contribution to society playing trumpet since it's not 1950 anymore, and I should get with the times and maybe do what all the kids are into. So I was writing techno and psytrance and playing at festivals and doing all that sort of stuff, and luckily I had a teacher at VCA that really kind of encouraged me to start viewing the laptop as kind of another extension of my creativity, and it's almost like the ultimate instrument. I was kind of, after 20 years of playing trumpet, pretty sick of the sound that was coming back when I played it. The novelty factor had worn off a very long time ago, and I decided that I was just going to try and do everything myself. Also at the same time I was going to these sort of big events and playing gigs, and it's pretty common to see at these big festivals like a big pyrotechnics display and laser light shows and VJs and sound, and kind of realised that the name of the game wasn't in just making music, but it was almost like you need to create a sensory experience, and that includes all facets of it. So at that point I wasn't even just content with making just the music myself. I wanted control over every single pixel, every single light, every single sound, everything. I wanted to create my own kind of experience in that form, I guess. Yeah,
one of the issues that we sort of find going to these gigs and festivals and stuff is that the lasers are awesome and the projections are awesome and everything, but it's really hard to find really solid gigs where everything is so tightly integrated and obviously integrated. Like a lot of the time you have a lot of separate people who don't really know each other working together in the same place, like someone doing visuals, someone doing lasers, someone doing pyrotechnics, someone doing the audio, and none of them really, like, they'll talk beforehand to plug in together, but and you might have one signal, but there's not like a lot of musical integration into equipment, or we just noticed a lot of room for improving.
There's lots of pretty patterns and pretty lights, but it really has no connection to the music that's happening at all, as opposed to someone just banging a button on the downbeat every couple of bars. And that kind of frustrated us. So that was what was going on there. And also at the same time we were kind of getting exposed to these other audiovisual artists that were really kind of pushing the boundaries with what the kind of field that we wanted to move into. So this is Ryoichi Kurokawa. I'll just play a quick video. Yep, those guys are great. And then obviously everyone's seen Ryoji Ikeda. This is kind of like this more immersive experience that we're kind of talking about, almost like being inside the computer's brain. These are like quite minimal shows, I think, but they show the synchronicity a lot more clearly. The relationships, correlations. It kind of represents the synesthesia that we're a bit more interested in. Yeah. And finally, granular synthesis, Modell 5. This single piece of art inspired me to basically do a PhD, and is the greatest 1 hour show in the history of anything. You can actually rent it out from the library, and I highly recommend you do. These screens are like huge, like it's so immersive. Yeah, it's such a simple scene, but it shows you just like the intensity. The intensity of it, I really like. My wife's a meditation instructor, and she's all about getting to this place of oneness through stillness and quieting the mind, where I decided that you could probably get there as well if you just bombarded the mind with so much stimulus that there's no room for any analytical thought whatsoever. So we're both kind of going through this, transcendent experience, but it's like a different kind of way. So I put this slide in here, which I thought was interesting. It was like how to get there. In the 1960s, there was researchers that were basically administering LSD to patients, and they formulated kind of a table of the kind of peak experiences that people would have. And I thought it was interesting reading it, like this sense of unity or oneness, transcendence of time and space, deeply felt positive mood, sense of awesomeness, reverence and wonder, meaningfulness of psychological and or philosophical insight, and this ineffability, sense of difficulty in communicating the experience by verbal description. I guess that's kind of what MindBuffer is going for, is these type of qualities from the experience.
Purely from the synesthesia of a performance.
It's just so overwhelming, and there's so much stuff going on that you almost can't describe it, which makes it hard for me as a researcher trying to write papers, because I'm basically trying to go for things that you can't talk about. And that's why I really struggle writing this stuff down, because I feel like I'm always underselling and not doing it justice when I put words to the paper, because it's just like experiences for 5 seconds and it's worth a whole paper basically. But it's my forever struggle. So obviously all this was going down, and I was in Ableton and Mitch was in Logic, and I really wanted to get my head around Max MSP. I'd had 4 false starts, and I really hated the fact that I was getting beaten by this program. So I'm like, screw it, I'm going to learn this. I'd finished VCA. I locked myself in the basement for 2 months while my parents just put food under the door, and just read the tutorials, went nuts, and I saw on Create Digital Music that Cycling 74 was going to have their first conference in San Francisco, and my parents, being awesome, decided to buy me a ticket and send me over there. So I went straight over there and got to...
Of course it got you out of the basement.
It got me out of the basement, yeah. So I got to meet Millett Puckett and Andrew Benson and all the guys from Cycling 74, and they got me up and running really quickly. And from there I kind of came back, and within a week I wrote some software and got accepted into honours at RMIT. And I was like, and that was also the point at which I got introduced to Jitter, which is the visual side of Max. It was really interesting to me building these like visual patches that I was almost kind of using the same part of my brain as I was when I'm being a jazz trumpet player. But I, for the first time, got to experience this like whole different medium coming back at me, and it fascinated me. That was kind of the turning point for me to stop writing music all the time and really invest in how to manipulate pixels to give myself pleasurable experiences. So I started working on like with OpenCV and stuff, and then wrote like a little VJ tool that I could start playing out with. And then for my honours, I wrote this software called Jitterbugs, because when I was playing with this stuff, I realised that there were these kind of aesthetic relationships between visual characteristics and audio characteristics. So for my honours, I really wanted to explore and go down that pathway. So for example, like a correlation I made was if you put a sound through a reverb, it kind of washes away the clarity and the crispness of that sound. But if you kind of blur an image, it does like a similar type of aesthetic relationship. So I would pair those two processes together, and then from a single control, achieve that same sort of aesthetic effect from a single parameter. So it was all about finding these correlations between the two, and basically either VJing and getting a sound output as by default, or playing with the sound and automatically generating this visual response that had some sort of relationship to the one medium. And that was good. I had a good time. And then
it was around this time that I met Josh, and at the time I'd just been working on composing in Logic, which is like a digital audio workstation. I'd always loved Logic as a platform for being able to compose any number of instruments. Like you didn't have to be a skilled composer for an orchestra just to lay out like some patterns and play something. But once Josh had shown me Max MSP, I realized that there's a whole different realm of composition like available there. So once Josh had showed me, we worked pretty hard to convince RMIT to introduce a Max course. And so the next semester we ended up with the first Max MSP course, I think it was, with RIT. And then during that, around the same sort of time, I was also learning that a lot of my favorite artists had been exploring generative music as well. So artists like Aphex Twin and Autechre and Square Pusher, like all these guys have been incredibly inspiring. Like people who are using computers to do things that you can't do by hand, you know? It's like using computers as new tools, like rather than just to create things that we could already make beforehand. And then once I'd learned about the idea of generative music, it wasn't just that it wasn't just the possibility that we could generate all the things that we spend so long doing by hand. It was that a computer never gets tired. Like the idea that, this opens up so many new opportunities. Designing the system that generates the music rather than just single instances of music. So at this point, I became really quite obsessed with the idea of generative music. I started, this is the first patch of Gen. It's like Gen is the name of my generative software.
Do you want to play some tunes from it?
Yeah, I'll play. This is one of the tracks that it made at this point. So at this point, it was just sort of, I would lay in maybe like 10 or 20 different patterns of different kinds. So I'd have maybe like a percussive sort of pattern, a melodic pattern, a bass sort of pattern, and then I would use Max to sort of morph between these different patterns in different ways and generate new styles. And I wanted to do it within a musical structure, so it kind of just changed every 16 bars or 8 bars. It was very primitive at this point, like very basic sort of musical ideas, but this was the first sort of thing that made me realize that maybe we could do this, and maybe this is something that I'd be keen on spending my life exploring, like to really exploit the potential in generative music. So I'll show you another couple like demos. So this is basically just plugging the same thing into different instruments. Skipping a bit. So I could pick different instruments and change between them like kind of meaningfully. It's more of a jazzy one. So at this point, it was just outputting MIDI data. So I could plug it into Logic, pick whatever like instrument I wanted to plug it into, and then it would just perform it with the MIDI data. This was just a really nice Contact drum kit I came across. Sounded really nice.
Yeah. So at the time, like we would like we were still releasing stuff under MindBuffer, and we'll probably get into that in a second, but we were using this tool to generate like melodies for us, and we take that into Logic and process it, and so it was a really great tool to even just spark ideas that we could then start resampling and doing lots of cool stuff with. So
it was the first thing that really got us inspired about like systems as an art form, like and really exploring not just these single, like, because art to us beforehand had always just been these single instances of creativity, like you make a song or you make a video or something like that. But then seeing this and like seeing how we could so tightly integrate like audio, Logic and visual all in one system was really inspiring, and I think that really started a new direction for us.
I think in the end it's like this concept that David Rushkoff talks about, like this technophobia or aphoria, where instead of saying like finding what tools are out there and saying what can I do with this software, just completely scrapping that idea and saying what is it I want to do, and then building the tools from scratch. And then you're completely liberated from anything at that point, because you don't have to work within the confines of something or squeeze your creativity into whatever Photoshop will let you do or to whatever VDMX will let you do. It's like you just have whatever ideas and build it all from scratch. And
it's hard to realize how capable you are of doing that too until like you get to play with something like this. It's like a really nice, friendly graphical user interface. You can move patch codes around and plug things in together. But you're designing your own software at this point, and like, you're making your own programs, and like you sort of realize, wow, okay, like maybe I don't need to be limited by what like Logic can do or Ableton. It's like let's see what can be done.
Anyways, then this happened. It's at this is actually a sub patch within one of my other patches for literally just trying to change the colors on my MIDI controller for doing presets. This is back when I had a really old laptop, and it actually took me like 30 seconds for my computer to catch up to make a patch chord at the end. This took me a whole day of making patch chords.
I can't believe you did this though.
I know. I posted this online and they actually made it the Max MSP Facebook banner page because they thought it was that ridiculous. And I'm like, all right, look, if this is the way things are going to go from now on, I think that we've outgrown Max MSP, and it's a great little prototyping tool, but in the end, our ideas are just like skyrocketing, and the fact of that the computer is limiting our ideas, and the CPU cycle is getting eaten up. It's like, sorry, Max, but you just kind of have to retire now.
Yeah, we see like years of future potential in this art form, and like considering we just started with Max and we're already running into like,
within 6 months,
and
it was just going downhill way too quickly.
Yeah, we need to find a bit more speed.
Yeah. Max is a great teaching tool and a great prototyping tool, but if you actually want to do like something completely huge and serious, the only way to really do it is to actually computer code it, like text-based coding. So Max kind of went in the bin at that point. And then, so we decided, all right, we've got these two things going on. We need to kind of form MindBuffer. After that, when we first met and had that bowl of tequila, we wrote one track and put up online. I think that was the next week. Jake, Sun Aquarius, contacted us and signed us to Enigmatic Records. And we're like, wow, well, that happened quickly. We've got one track and we're signed already. Maybe we should...
to all of our favourite artists.
Maybe we should actually keep doing this. And that was probably, I don't know, it was the start of the year or something, and then they wanted to have a launch for the label at Brown Alley within a few weeks later or something.
With an hour-long set.
Hour-long audiovisual set, like at peak time. And we're like, holy shit, we need to really
make some music.
Actually make some music and stuff. So, Mitch came around and stayed at my house for 3 weeks, and we didn't sleep and didn't do much else but drink tequila and code nonstop. But we got there, and this is what we ended up doing was... grabbing all the tracks from Logic and basically stemming them up. So we get all the drums tracks, put them into a bus, bounce it out, same with the bass, all the atmosphere tracks and glitch melody sort of stuff.
Yeah, we weren't using generative stuff with this yet because we still couldn't quite get the detail and the quality that we wanted to out of handmade composition. So because we still wanted that quality, we're still spending a lot of time like making a lot of songs and like visual stuff by hand. And
so what we do is then we'd bounce out each part of the track into like an 8-bar or a 16-bar loop, and then stemmed, and we'd bring them all into Ableton, each different colors like a different track, and we'd literally just move down the line. But at the bottom of each track, I wrote like a little Max for Live device that basically was pretty basic, just summed a normalized value between 0 and 1 of the volume at any one time, and then would send that, hopefully over OSC, when the network wasn't down, into my laptop, and then I could just basically take any of the volumes that are coming in and then pipe that to like a visual process basically. And that was cool. This is our setup for our first gig, which we never did again, and I only put this up there because I recommend that no one ever does this. This is our kind of first ever show doing this. So
at this point you've been playing around with processing?
I went from Max into processing, which is a Java based creative coding language. So basically on Mitch's side, he had Ableton running. I've had all these Max for Live devices at the bottom for each of these tracks, and it was sending over into Max on my computer. And then I had like Max is like this brain basically, and I had a Jazz Mutant Lemur that I could interface it with. And so all this data was coming in. I would press a button which would then execute a shell script which would find a processing patch somewhere in my computer, open it up, then I'd compile the code live on stage. I'd send that to Siphon, and then that would get sent to VDMX, and then I would put that onto the projector, and then while it was going, I could like just basically push parameters into like different visual things, and then for every and then I'd be finished with that, and then I'd like crossfade into some just weird ambient visual textural thing, close processing, launch another shell script, recompile another bit of code on stage. Anyways, I just did this for an hour, and it was 2 a.m. We'd had a few drinks, and I realized pretty quickly. We definitely
could have done this a lot better, but at the time we were so new to coding, like so new to just programming in general. It was amazing to us that we could even get this running and like plug in together.
Compiling code on stage nonstop for an hour is not conducive to a happy experience.
Not recommended.
And so we bailed on that idea at that point. And the thing is, we were relying on Max, on shell scripting, on processing, on Siphon, on VDMX, on Ableton. there were so many different parts in the chain that could go wrong that if one failed, the entire thing would just be dead. And you work so hard to get this done. And I think it was really great for me to go through this experience because it was kind of at the very start of my PhD, and it really inspired me to go, you know what? If there's something in Max that I need, I'll build it. If there's something in VDMX that I need, I'll build it. If there's something in Siphon or whatever it is, I'll just build all of that into the one unified bit of software so that there aren't like all these different things that I'm relying on. If I really like the blending or whatever it is in VDMX, then I'll just code all of that in C++ and I'll have all of that. So
at least if it goes wrong, it's your fault.
Yeah,
and it's,
you can't blame,
it's something that you can fix.
Can't blame VDMX.
Whereas, yeah, you're not limited by like what the different pieces of software offer.
Yeah, so at that point, I just decided to ditch all of that, even ditch processing, and just purely focus on open frameworks, which we'll talk about in a sec. Well, I'll talk about it now. So open frameworks is like processing. It's open source and it's amazing, but it's using C++, so it's really an OpenGL. It's really, really low level and close to the hardware. And I basically decided I was going to teach myself how to code at that point. And this is our first little patch. I was just using GLSL shaders, which are tiny little scripts that run on the graphics card. And it was great. It was like the speed I was getting from these shaders were like 1,000,000 times higher than I was getting in processing. Everything was in there. I could do all the mixing and things were great. So I'll just move through this quickly because I know we're running out of time. Anyway, this is kind of a version of what was going on at that time. So it's all reactive and things are going great, and I can just map it in real time, and it was the one bit of software, and things are good. It looked fun. So let's move on. Next.
What year was it?
That was 2 years ago.
Was it?
Yeah, 2014. Or maybe 2013. Something like that, 2 and a bit years ago. Gen AI.
Oh, yeah. Yeah, so at this point, Josh had started on open frameworks and and I also did, because we're both looking for a lot more speed, so this is where we had to go. It's like, it was a creative coding framework still, similar to what we'd been used to, but it offered low level control. So C++ is a very high performance programming language, but it's also very easy to shoot yourself in the foot as a result. So,
it'll let you run off a cliff really easily if you want.
Yeah, it does exactly what you tell it to, which is why it's really fast, but also very dangerous. So at the same time, we've been working this together. I've also always been interested in gaming and game soundtracks. I'd been working on a soundtrack for a friend in Belgium at the time, and I also realized the potential for generative music in gaming. So traditionally games, maybe they have 100 hours of gameplay, but at most they ever have maybe 2 hours of a soundtrack. And so you always whatever environment you walk into, you get very familiar with the different loops that can play, and maybe they'll have different variations of the loops and stuff, but it's always the same sort of thing. So I realized very quickly that if we can get high quality generative music going, there's a whole new market there, art form, and potential for integration with games. Not only would you have infinite music, potentially infinite sort of source of music in comparison, you also have much tighter integration with your real-time feedback. So because you can pass this so much more data directly from the game itself into the generative software, you can produce things far more spontaneously and accurately. So if you walk into a massive big battle scene or something like that, then maybe your instrumentation dials up massively, the mood changes and your scale changes. All of this can just happen in real time if you can get the software right. But as we'd just been introduced to the potential of systems, we realized that this is possible, just a matter of putting in the work. And to make this happen, games are already so CPU intensive. I realized that I needed to get a lot of speed, otherwise people aren't going to be interested. Playing back a soundtrack is very cheap and very efficient because you're literally just playing back samples. Whereas if we want to generate music in real time and render it in real time, then this was going to be a whole new
and not get in the way of the rendering the game engine either.
Yeah, it's hard enough to convince game engines to allow some like basic sound effects on top, let alone whole generative engines. So I realized that I needed to get into low-level coding to really make something that could be, something that I could use for that as well as MindBuffer. And so, I wanted to make this big master version. So open frameworks it was.
Do you want to play? Get into this.
Jump past me there. Oh yeah, sure. Yeah.
So I mean, this is kind of the first version of that software in Open Frameworks, and then sending the data across into my computer.
We were down at Josh's Spokes Beach Hut. Had a lot of tequila at this point, and this is the first time that we'd ever been able to plug in from our own software, like our own low-level, high performance software. And to see this, we were just so ridiculously stoked. Even like as shit as it sounds, it was just like the fact that we could get data going across in real time was.
And this is going into just a shader, so you can see it mapping. So I've got like a correlation matrix in the top right, and I can just kind of like say, okay, so the kick drum volume can go to the bendiness of the wave or something, and just making these different correlations just to kind of explore this real-time feedback of having like a visual representation of the generative beats that are coming out. Super basic, but it gave us hope that we're on the right track.
Yeah, it's just an example of like the amount that you can do more. You can do so much more when you have a lot more than just one signal, because normally like when you're playing live you might have a couple buses or something like that, but we had all the musical information, so we could pass every individual note, the pitch, everything, and this was just like the first tiny glimpse of what we could do.
So there's like a lot, instead of before we had like the drums, bass, melody, atmos, it's like 4 different volume channels, but if you think about the data that actually makes up music, there's so much in there. There's like all the different playhead positions, there's the volume from the buses, there's the pitch information,
the phrase progression,
there's just so much. I tried to like outline them here, you probably can't see. So the whole goal at this point was like, all right, we need to package up all the data that's happening in Gen at any one time, and then send that to my computer 60 times a second, and then I can unpack it and then
display visually,
spawn it out to audio visual events, I guess. And then so then Rusty time.
So at this point coding had definitely, I'd realized it was the most liberating tool I'd come across yet. Like even compared to Max, like Max was a lot of fun, and it was very like it had a lot of immediate feedback because you could see what you're doing, like plugging in patch codes. But the more I got into coding, the more I realized that a graphical user interface can in some ways be a bit of a limitation, because you're kind of limited to what you can reach on a 2D plane. Whereas once you're coding, you're literally just talking about a system, and like you're basically limited to whatever you can, whatever you're capable of describing. Or you're not really limited at all, to be honest. It's like that was what was so exciting. It was also the most sort of communal tool I'd ever worked on as well. I'd realized like it was extremely humbling, because I realized very quickly that no one writes everything from scratch. Like everyone in the coding land is standing on the shoulders of giants. Like no matter what point you are, like unless you're literally writing zeros and ones and like the drivers of your firmware or something, then you're working with someone else's code and like someone else's libraries or something like that. So at this point I also became very interested in a new language. So because I'd been becoming so interested in programming languages that I was getting about as excited as exploring languages as I was with the music. So I came across this new language called Rust, which is as fast as C++, but it's much more modern. It's developed by Mozilla, and they developed it to because they're currently developing the world's fastest new browser, which will hopefully overtake Firefox pretty soon. One of the awesome things about it is that before we mentioned C++, it makes it so easy to shoot yourself in the foot, whereas Rust, they've solved the problem of allowing you to have a lot of speed without allowing any memory corruption or anything like that. So I got really excited about this. I felt much more comfortable and liberated like coding with this. I wasn't spending weeks debugging pointer errors and whatever, because this language saved me from it. But as a result of using such a new language, it meant I had to make a lot of things that didn't already exist for it. So this was just a whole other realm of time spending. So at this point, like this is my my GitHub repository. like when I was talking about like how communal coding is before, GitHub is a great example. It's sort of where you go to share your code and work with other people on code. You can like with songs, I guess you can like in the same way that you can pass back tracks and whatnot. With code, you can swap around different pieces of code. But GitHub is a really awesome way of collaborating because you can contribute code, have people review it for you, like literally comment on each line and say like what they want you to do or what they want you to change, and then you can merge it in together. So at this point, because it was such a new language, I had to make a lot of new things. So I ended up developing my own digital signal processing graph, my own graphical user interface libraries. And this was the price I paid for going to this new attractive language, rather than spending
Rust, port audio to Rust.
Yeah, exactly. Yeah, port audio to Rust. So rather than spending time on debugging like memory issues, I was now spending time on writing all these libraries that didn't exist. So everything from the GUI, the DSP, then I could make the synthesis on top of that. And then this is just my commit history. You can see down the bottom there. I think
2,000 commits in 1 year.
Yeah, 2,000 commits for that year. I think it's like 2,500 at the moment or something. But
so I go into.
Yeah, I got sucked in at this point. But I go into. So this is the just a really shitty example of the GUI that I'd been working on from scratch. So literally writing all this logic from the ground up. Like, all right, I need to draw a rectangle. Okay, I need to draw text somehow. Okay, now I need to organize these things to make widgets. All right, how do I make it react? All right, I need this, there's a whole other rabbit hole of time spending. But now most of this is done, so I'm back to actually having fun and working on the creative stuff that I want to work on. But just be warned that it is so easy to spend so much time on things that you could not foresee whatsoever.
You just have to remember that the goal is to actually make music. And to do audio, and 3 months later when you're still trying to get something to a scroll bar to work,
it's very humbling.
You just need to remember that it's for a bigger cause, and this is
exactly.
And then I'll go into synth editor.
So this is the synth editor I'd worked on for Gen. So at the moment Gen only has a single instrument and it's a synthesizer, so it's all native. It's a really basic synth. It's just a polyphonic envelope. Like you can envelope the amplitude and frequency of each oscillator, and then just combine multiple oscillators together. So this is just me mucking around, making sounds with it. So the way that I was working with Gen at this point is that I would write a bunch of instruments, like just really basic synth instruments, and then Gen would basically scan through the instruments, analyze them, and then work out what would best be used for different kinds of patterns. Next slide.
So this is all the data that is getting spat out into my laptop 60 times a second from Gen. It's kind of blurry.
We don't normally print all this out, but it just looked awesome, so we thought we'd record it out.
So that's like this big string that gets sent like 60 times a second, and then I grab that data, I unpack it, and then package it into certain containers, and then send that out into different processors. So this is kind of like the neurons that connect our software, I guess. Yeah, exactly. Which is quite cool.
And Gen itself is made up of many different libraries. There's the synth editor that you saw before that I used standalone. So there's a whole synth library. There's time calculators. There's pitch calculators. There's multiple different libraries. Most of the libraries are actually open source now on my GitHub that I showed before. I think maybe got a link at the end or something. I don't know. But and then I use all that to build a new library on top. So the core of Gen, where it handles all the audio synthesis in parallel with the user interface that I can actually interact with it. And then also, sends data to Josh in real time. And then on top of that, I can build my own custom pattern generators or phrase generators for generating phrases, generating patterns, and then I can use different generators and instruments in different combinations in different projects. So I can have a project dedicated to maybe some game, and then I've got a MindBuffer project which I'm constantly developing. So I wanted to make this as flexible as possible. So the way that Gen works is most of the the spontaneousness comes from just shaping randomness, basically. So and not just sort of like yes or no, like, but actually using like Gaussian noise and different kinds of noise to massage randomness into sort of aesthetically meaningful ways. Yeah, so you're working with really expressive probabilities. So I want this to happen at a probability of this, and I want this to happen at a probability of this, but also being very careful not to get stuck into niches. Like whenever you're saying something like, I want this to happen 1/100th of the time, then you're probably on the wrong track. Like otherwise you're going to end up with lots and lots and lots of like special cases. Whereas what you want is the simplest rules possible to generate the most diversity as possible. That way you've got a lot more flexibility. It's a lot easier to change it in real time, and you don't end up with this massive big list of special cases. Oh, I want it to generate this kind of melody sometimes. Like rather than doing that, you want it to sort of fall out of like the simplest possible algorithm. And then you shape these options by applying probabilities in different ways.
Cool. Yeah, so we'll move on quickly because I know we're running out of time and I want to give some demos.
Sure.
But yeah, so this is Kortex, which is the software that I wrote for my PhD. And I'll just quickly go through all this. So yeah, developed with open frameworks. As Mitch said, I'm just kind of standing on the shoulders of giants. And so there's, for the audio, I use Maxim. There's timeline support in there. There's user interface support. I've got my own shader editor. And it's basically just collecting open source libraries, building on top of them, adding my own little features, and it was all good. My whole PhD research was kind of finding, as kind of an extension of my honors, was finding these correlations between perceptual characteristics between music and art. So I noticed that there was like similarities between the two, and the whole aim of the game is kind of making these connections. So for example, I made this little table, like on the left is some musical parameters, and then on the top is some visual parameters. So say if you have the loudness of something, you could say louder is bigger for a shape, or you could have an inverse correlation and say louder actually equals a smaller shape, which I always find these inverse correlations a bit of a, that kind of does my head a little bit. But yeah, there's just kind of an easy way to see how you can kind of take one characteristic and another characteristic and make these kind of relationships. So yeah, this is kind of what I did. I had these modular assignment matrices, and then I would find like some similarities that I liked. So as you can see on here, which is basically taking digital signal processing audio techniques and taking post-processing visual techniques and then making these correlations. So this is kind of the heart of what Kortex is, I guess. And then I was also really into granular synthesis. It's like my favorite audio processing technique. And I thought if I can just kind of work out exactly what's going on, I should be able to apply the exact same technique to visual material and come up with visual granular synthesis. And then from that point, I should be able to merge the two together and have audio visual granular synthesis, and it should be great. These are some of this is Gaber's first invention for the first ever granular synthesis machine in the 1940s. Very primitive. And then on the right, we have Rhodes's tool that he got to use when he made the first ever electronic granular synthesis instrument, which took a week to produce. We're actually living in the golden age of this type of stuff, so it would have really been bad for those guys.
We didn't have to patch it together.
Yeah. And I'll skip over some of this stuff because I want to show some software. Yep. So yeah, it's basically the whole concept of granular synthesis is you start with some audio or not, but in this sense you do. You dissect it into tiny little grains, usually between 1 and 100 milliseconds, or just long enough to activate the auditory system. And then from there you can spawn thousands of these in different ways, and for each individual grain you can control like the panning or the position or the density and the pitch, all these different parameters. So and then you put it all back together and you've got something else. Or you can just leave it alone and it sounds like normal. But I really like this almost like, I use the word God level control over audio. So I really decided to sit in this area. So for visual granular synthesis, I needed to define a grain in the first place. With audio, you have this segment of audio and then you apply a windowing envelope on top of it. So I was like, I'm just going to define a visual grain as a selection of frames, and I'm going to pair that with an audio grain, and then I'm going to apply a grain envelope. And obviously the grain envelope in granular synthesis as it is controlling the volume, and I'm going to make a correlation between the opacity of the image and the volume of the sound, so you can kind of get this fade in, fade out. and then we'll just overlap them all, and everything should be great.
Yeah, at this point, there's been a lot of research on audio granular synthesis, but not a lot at all on visual.
Yeah.
So a lot of this was like exploring, like how do we take the same like process and put it on visual land.
I've got a paper out there if anyone's interested on how this all works. And then different windowing shapes gives you different aesthetics. So this is kind of like 3 overlapping visual grains. You can kind of see them fusing on top of each other. It's like this time dilation effect where you kind of can see the past and the future at the same time, and it's quite cool. So then the whole point, I realized is, all right, I've got thousands of variables I can control at any one time. I've gone down, I've coded all this stuff, I have God level control over these tiny little microseconds worth of stuff, but I want to still perform it like a jazz trumpet player in real time, and I want to control thousands of things all at once. So at this point, you kind of need like some pretty serious performance strategies, in the sense of using presets and then having like different transition shapes from using them. Algorithms like simple harmonic motion and Perlian noise and all these different types of things you can just kind of feed down into it, and then you kind of have this like conductor level relationship with your software in that sense. And you can spawn off something which then filters down into all these different things and makes stuff happen instantly. So just in wrapping up, for future dev, I want to have user assignable LFOs. In phase 3, I've said DMX and laser control, but I've just got too excited to move that to phase 1. And yeah, we've got this big routing section. One thing I really want to get into is, at the moment, I have like this sort of really micro level audiovisual granular synthesis happening, but then that gets fed into a master stream which does digital signal processing and post-processing stuff to the final output. What I'd really like to do is do micro post-processing. So each individual grain has its own downsampling, reverb, pixelation, everything on top of that. So you have one grain that has a small reverb and another grain that's overlapping goes into a longer reverb, and then this micro effect thing going on.
Yeah, the same control that you got over the actual grains.
Yeah, the same on the processing as
well.
well. And then for Jen?
So the next step for Jen is to actually launch the site. So I mentioned before that not only do I want to do MindBuffer with Jen, I also want to do game soundtracks. So it's been a mission, like developing the software to get it up to this point. But finally, so close now. I've been saying that for a while though. But so the site will be next to finally do the commercial release of that. And then also right now, Jen's sounding very dry. I want to get some effects processing going. So in the same way, similarly to how I generate like patterns and whatnot, I'll be generating effects automation. So like selecting different effects depending on the patterns generated and the instrumentation chosen, and then generating like the automation envelopes and different ways to interact with each other. Then at the moment, Jen is also restricted to a single synth. Whereas I wanted to be able to play like whatever instrument. Like my interface for instrumentation is generic, so it should be quite easy to develop like a sampler to play back actual real found sounds. Rather than just like really basic synthesis.
And plugging that in with like neural network research that we're doing at the moment in getting it to kind of like train it on a sound. That'll be phase 3. That'll be like our long term is to move off of just using probabilities and basic randomness to generate things. We want to actually we realize that in setting up these big probability networks, we're very limited to our own ideas. So we're basically limited to what we can come up with and like the decisions that we decide on the spot. This is very nice. Like it's really fun and expressive, but we'd always just be limited to our own ideas. So machine learning is basically the final frontier for us, and like properly exploring artificial intelligence and applying machine learning algorithms to take ourselves out of the picture more and sort of see how much we can automate these like decision-making processes. So we'll kind of like, our plan is to work from the ground up with these generative algorithms rather than like just replacing one step of probability at a time. So sort of just peeling it back. First, learning how to recognize instruments, training the software on like pre-existing music from recognizing instruments, recognizing the patterns, and just playing with that whole massive wormhole of I'm happy to announce that we have actually got instrument recognition going on as of like a couple of weeks ago, working with computer science guys. And so that's great. So next step is to actually get to hallucinate its own sounds based on the spectral information that it's learned from those different categories.
So rather than having to actually just sit there and design meticulously each sound that Jen can play or whatever, we want to actually have it hallucinate its own sort of designed sounds.
Well, say for example, I've trained this neural network on 2,000 kick drums and 2,000 snare drums, and it knows the spectral components that make up those two categories. And now I can play it a kick drum or a snare drum it's never heard before, and it can recognize what it's listening to with 98.9% accuracy.
Yeah,
so instead of actually feeding it in there, you just say start with that category and just dream up something that makes up what you think would be considered a kick drum, and then give me the spectrogram. I'll convert it into audio, and then we've got a brand new kick drum no one's ever heard before.
Yeah. Some neural nets allow you to not just train it, but sort of flip the weights and spark. Yeah, like give it the output that it would normally return as an output, and then return what was previously the input as the output instead. So you can rather than just training it, you can feed back the actual audio as well.
It's quite complicated real quickly, but it's good. That's I'm just going to quickly show you some software demos, and then we can have some quick questions, and then it's been fun. All right, I'll just quickly show you Kortex, because that's probably the biggest one quickly. Software, single screen. Cool. So basically the start of it is I've got a 10-second ring buffer worth of memory, and I'm just constantly recording and reading and writing and deleting all at the same time into this buffer that's going down the bottom here. I don't know why I have a wheel of death. What's going on there? There it is. Looks alright. I can have punch in some content like these guys. Some people doing their thing. So I've filled up this buffer now. And now it's just reading and writing from this one bit of memory. When I did my PhD performance, it went for 20 minutes, and I think I wrote and deleted about 15 terabytes worth of memory in 20 minutes, and it didn't crash, so that's fucking awesome. So now I've got this, and now I can sort of slow it down with some granular synthesis. You can kind of see it there. I'll turn it up a bit. There's basically these overlapping visual grains. Just kind of merging in and out of one another, which is quite cool.
We have a lot of fun just finding content to plug in and just mess around with. But
on top of that, then I have some digital signal processing stuff. So let's say if I downsample it, I can. Let's turn up.
Gotcha.
There you go. So I can like crush the audio and pixelate it, or I'll put a flanger. Say reverb, wash away the parity, distortion. Just like making these kind of relationships, which is quite cool. Then on the other side, I'll just turn these guys off. Then I have a full shader engine over here, which I'll just launch up here. So I've made all these parameters that I can tweak, and then move it up and down. All this stuff's happening in real time, so I can just punch a few of these in. Also, I've got a real-time shader editor in here, so I can actually write GLSL code within Kortex straight away. And this script that's on the left here is generating that pattern. And if I make a uniform variable, it just shows up as a GUI element, and it also shows up for me to instantly map it to incoming visual audio parameters coming in from Gen.
Do you have the routing section there?
Yeah, so then this routing section is kind of like...
So the audio parameters are coming in those, like over an OSC.
Yeah, in real time over OSC.
We package it down into a real special little string, and then unpack it.
So then on this side, I say I have these different parameters. So like say the brightness, I can select that, and then on the incoming one, like say if I just randomize all these LFOs, you can actually see the data that's coming in real time that I can map, or I can take it from a reordering module, the volume of Kortex, or Gen. And within Gen, I've got all the different instruments. So kick drum, snare drum, ghost, bass, melody. And then within each instrument, I've got like the amplitude, the percentage through the note, and the pan. All the playheads like phrase, segment, minimum, quaver, semi-quaver. All the buses and the master. It just gets ridiculous. But for example, if I just map it to like an LFO, then that LFO1 is now controlling the brightness of this. So you can kind of see how it all works. Basically, we have a bunch of parameters that can either go to an audio-visual granular synthesis part, to a digital processing part, to the shaders, and then
it's like a bunch of different controller inputs, and then a bunch of different possible outputs.
Exactly. And so the next phase is not only have it go to like a visual element, but pipe it off into control, DMX control, lighting control. So for strobe lights, to moving heads, and writing a full ILDA laser beam software in C++ at the moment, which will go into this. So then baselines can come in and I can spawn that off to open up the laser, and then snare rush will come in and go to all the different strobe lights, and then something else will come in and that will go to the granular synthesis. So you have this big interplay between the entire venue of different sensory elements, which is literally just getting generated from there. Yeah. And I can populate all this sort of stuff, or I have all these different presets, so I can save every single one of these things. I can save as a preset, and I can tween between them. And so it's like we use a studio to create these correlations and these relationships, and then on the gig we're just kind of just massaging and regenerating and making sure everything's
kind
good.
of just conducting the whole thing.
Exactly. And I've got full timeline support. Every single parameter in Kortex can be automated as well, or it can be generative, or it can be controlled from OSC or from the user interface. So it's all quite large. It's 5.5 years of programming.
We must have more than 100,000 lines of code.
Easily. And just before I'll just quickly show you this ArtNet stuff I'm doing at the moment. So this is a simple harmonic motion algorithm, and we're using, because we want to, obviously we want to play with lasers and we want to play with DMX lights and all that sort of stuff.
We can't afford all this good.
We can't afford hundreds of thousands of dollars worth of stuff. So I'm using this program called Capture, which allows me to basically create my own little mini MindBuffer setup. So there's me and Mitch, doing a good time. And I can pipe in the visual output from Kortex in real time. And then for these DMX lights, then from Open Frameworks, I can then say, all right, for the on and off, I can just control them, or we can do stuff with the heads moving in different directions, and just basically a proof of concept so that we can play with the relationships eventually and actually visualize what it's going to look like.
It'll make it much easier to come to promoters as well, and actually convince them to have our show and actually how prepared we are.
I'm working with a developer in Sweden at the moment to actually work out how we can send ILDA frames over
the laser beam.
UDP into lasers as well, so we should be able to simulate all lasers as well. Getting the atmospheric lighting and all that stuff is a bit
of machines.
Anyways, I could talk about this forever, but so I just wanted to quickly give you a little look. And finally, the last thing I'm working on is, I don't know if anyone went to Robert Henke last week, the awesome laser show. But I've really been trying to work out for the last 6 months how I can control this laser beam I bought. So I wrote software for 6 months and it was great. And then I saw the show and decided I'd delete it and start again. So now I'm trying to work on like these path tracing algorithms to control laser beams in different ways. So the basic idea is that you start with a simple shape, and you can control like an n-gon or a polytope, and you can control the number of sides it has. Instead of saying I want a square or I want a rectangle or I want a tetrahedron or whatever, I just wanted to get all those shapes from one slider. And then from within there I have a thing called octave. So instead of sequentially connecting vertexes to the next one, we can do every second one, create stars and create some really crazy looking shapes. And then from within there I want to create like a different ways of path tracing basically. So I can draw points on sequential and then trace them around this shape, or I can do bidirectional and get these blue ones. And then from there we can either connect the lines to create like these kind of super shapes, and
different ways of expressing
different ways. So you can find some really nice looking patterns within them, and then use them as the actual locations that a square or cone will go, or I don't know if that's probably it's way better when you actually see it in the laser. But it's a real massive head twister writing laser beam software on the screen, because you're looking at this final result, which doesn't. It's hard because you want that final result to look really sexy, but it doesn't really matter when you look at it from the beam coming at you, because you can't actually see that pattern anyway.
The beam also has all its own limitations, which is it's really hard to be conscious of without actually having it.
Well, I mean, you can't see, you won't see this.
You won't see
this
visualization of that.
Like you won't see that shape.
I was going to ask you about that, because it's very similar to doing more complex structural work in spatial sound.
Yeah.
That in equivalent of that. So
exactly.
Space.
you can't just like
Well, the way I
whip
write
up the space.
I
So-
write up and explain it, so I'm a little bit much next week. I describe it as it's a notation.
Right.
Yeah.
It sort of it describes part of what you're going to experience.
Yeah.
But
not the whole thing.
It's not saying you will hear the sound whiz around in
Yeah.
this particular
Yeah.
auditory,
Yeah.
and that's what you're going to hear.
Yeah.
Yeah, so yeah.
Yeah, it's been a real head twister getting my head around it, but it's
Yeah.
it's great.
So what do you see with that?
Mm.
What is the relationship between that particular
So you can.
interface that we're looking at the moment and what we might see?
So that's kind of like if you're looking directly at the laser beam,
Yeah.
which is probably not recommended.
Mm.
But that's the kind of patterns that it would project out. So if you were to stand to the side, you would see that
Yeah.
sort of like
But like, so within that, I've got like the size or something. So the baseline might come and go, and then it might disappear.
So
Or-
as you start to experiment with it, you've got more lasers and things. What you'll learn is, or work out, okay, if I've got this, then it's going to look something like
Exactly.
Yeah, exactly. Yeah, and it's kind of like
shortcuts or something.
we want to get those limitations into the software as much as we can as well, because like it's not just sort of like what's it going to look like. It's also the laser beam is limited to how far it can travel and draw the actual beam itself, like and the path that it can actually traverse. So sometimes we might have this awesome looking thing and plug it in, and it just looks like a total mess because it doesn't even get halfway through the path. And it's like.
But yeah, I mean, within like Perlin noise to offset the vertices and stuff, like I feel like I just wanted to build something that's diverse enough for me to create a lot of different patterns that I can then plug into. I don't want to have to specify 1,000 different things. I just want to, it's just an experimentation at this point.
Yeah.
But really keen to actually get full-on laser show in MindBuffer coming up real soon. And I'll show Mitchell to show him one thing, and then we can have some questions.
I've already had a big rant about Gen, but
that's good.
I'll just
Keep ranting.
no. So it's really difficult with like the actual audio part because I don't actually need to like. Well, I haven't spent a lot of time writing what I actually need to see what's going on. So I've been writing like all the generators and everything for a long time, and I've been limited to like literally just waiting and listening through the whole thing to see if it's doing what I want. Whereas now, oh yeah, sweet, it's up there. I've actually been. I realized I need to visualize the actual patterns that are being generated. So, all right, I'll make this little like piano roll thing. But I also need to visualize the actual automation lines, as well as like, so I've got a toggle here, automation line here, piano roll here, like bang, singular events. And now I'm quickly realizing that it's just turning into a whole door itself.
Yeah, it's basically,
It's like-
we need to write our own version of Logic.
Yeah, exactly. But it's like, rather than being designed around like manually sort of like placing everything in, it'll be designed to expressively like generate things and like shape the generation of different things, generate different things at different points, being able to do it live, like on the fly as well. Because when we play live, we want to be able to do purely generative sets, like sets that we've never heard before and no one's ever heard before. But we need to actually know what it's going to be doing. Like when we generate it all out, we want to know that it's going to do what we want it to do next, and we want the control to be able to sort of like regenerate things in different ways as we go. So this is the first step towards that. But this is just like a basic demo, but very soon it'll be much fancier.
Yeah, so that's kind of it.
Yeah, that's it.
Cheers.
Yeah, sweet.
Questions? Have you had any questions?
No, we just kind of,
I've got a question.
yeah.
So, amazing hearing this journey from being instrumentalist, you were going to the trumpet and the violin and then through to this stuff that I don't entirely
Rabbit hole.
get. It sounds like you're bringing your computers to life to dream and hallucinate. So there's a big trajectory, but how do you feel about the violin and the trumpet now? Does it change your thoughts about it or your relationship with those instruments, and do you see them coming back into this universe you created?
I miss playing it sometimes, but I just don't miss it as much as I want to see this do awesome shit.
It's like it's like comparing a horse and a cart to an F1. It's like, it's nice to have the horse and cart in the gallery still, and like it's a nice historical thing, but just get in the F1 and get where you need to go,
It's like, I think it's more of like,
So you see those instruments as redundant?
well,
Almost.
like
I don't know.
I think like it's not really that redundant. It's more just that like we only have a certain amount of time. We already spend so much time as it is making stuff. It's like to have the time to like try and work out some way of like working on classical instruments, as opposed to say working on artificial intelligence or like deep learning algorithms so that we can classify stuff. I think this is just a bit more exciting, and it probably will be for forever. It's like, I don't know.
They're just like, I mean, violin and trumpet's been around for a very, very long time, and there really isn't that much that you can do aesthetically with those instruments that hasn't been done in some form or another. And
so there's a lot of instrumental composers would totally disagree with you.
well, I'm not saying in terms of composition maybe, but
I
in
wasn't
terms
game
of
enough to say that. But
in terms of the actual in terms of the actual sounds you can get out of that instrument, you're not going to suddenly just come up with something that's like, holy shit, there's a portal that's open because you've just found this one sound. It's like it would have been found already.
What about live processing?
I'd still disagree with that.
Okay.
Like, you still hear pieces where that's an extraordinary sound that you've been instrumenting, but it's not necessarily about the moment percent, it's also compositional and what's
Like I still love when I go back to my hometown and drive around, like I'll put on classic FM and I miss playing with orchestras, and I love and I definitely see like potential there, but it's just not. We just don't find it as exciting as
it's whatever you feel like it can actually allow you to express your own creativity as much as possible. And if people can do that with traditional instruments, then that's awesome. But for us, it's not really about, I don't really think about just music or just visuals or whatever. I think about this thing that is alive that I can step inside, that is like going to heaven for a couple of hours.
The art of systems.
So because again, just talking about that, it's almost going from your comment about being instrumentalist, and you've been talking about high-level control and moved to that level as well. Every time you both said something today, you've done this.
Yeah.
You've got this whole gestural language. I'm just wondering about gestural interfaces. If you've thought about that for the next. You're going into eventually getting this up to the point. Yeah.
So far we've just been spending all of our time on actually getting the core stuff done, like in the automated composition, the actual being able to actually even process the kind of visual stuff that we're processing, and then I think very soon we'll get like more to playing around with different controllers and like being more expressive with it. Like right now I'm still just trying to get a GUI going, but once we get that going, like we'll work on different controllers and see what feels really nice to play and and explore different stuff, because there's so much awesome stuff like around these days.
And that might be a connection back to your previous musical. It's going to be also when you do that. When you learn an instrument at that age, like you're at that point where you've got brain plasticity researchers say that we actually never lose brain plasticity, but you're at a time when you're very physically and neurologically, you're very absorbent and that sort of thing. You're spending all that time around music and sound and doing the gestures, and I've always found it interesting when you listen to people who have had some kind of instrumental background going to electroacoustic music or electronic music, and those that don't. Really different attitudes. So your stuff is entirely polyphonic all the time in a really interesting way. Now that you don't always hear that. It's great, but no drones. Thank you. Only because of what it does to the sort of just what it does to your musical imagination. It just grounds stuff in a really in a really kind of potentially turgid way, unless you do it for training really cleverly. So I think probably in your ear, I think that's what I'm interested in the gestural side. Like what might you do with that?
We've
got some friends who are like deep into it as well. Like,
I mean, I've definitely had a go at it with like the Connect and the Leap Motion and all that sort of stuff, and
even like the emotive headset.
The emotive headset, and
controlling headsets.
I like the concept of it, and I started out, and it's weird because I was an instrumentalist for so long that I probably should be more into it.
I think it's just like compared to the sort of like detail of control that you feel under your fingers, like when you're like playing, it's like not quite.
It's like,
that's
exactly now this enormous landscape of parameters and
exactly. You can just fade down. I still don't think there's a interface. Just to interface it
up. By the time we're ready to like work on controllers, I reckon there'll be some awesome stuff.
We'll just build our own at that point. But I mean, I like the concept of the emotive headset. Like for me, I was saying this in the PRS the other day. It's like just the fact of using the Leap Motion, having to lift my arm off the table up here. I'm using all these muscles in my arm here, just do that, and I hate that. Like the fact that my fingers have to move on the keyboard is almost exerting too much bodily energy for me. I literally just want to download my brain into the internet and float freely forever. So that's kind of really where I want to go. I like the whole idea of gestural interfaces, but in the end, you only use gestures so that you can take what's going on in your mind into something else, and I'd rather just remove the body altogether and just be inside the computer with my head, I guess. But I just think we're still a while away from being able to do that. Yeah,
we definitely sort of progressed a bit more from starting in the performance realm, and like definitely progressed a lot more into the composition and conducting and the design of systems and But I'm sure we'll get back there one day.
We'll get there one day.
Any more questions or comments?
Are you planning to go to 9 next year with this project? It's going to be in Brisbane.
When is that, next year? It's like,
Next year in Brisbane. So.
It's in Brisbane, isn't it? Yeah.
what part of the year? It's like, do you know when it is?
Do you know when it is?
I don't know. I think it's in the insurance. I
Yeah.
was about to say something.
Yeah, I think
Yeah.
it's is it July? Nime is usually around.
Yeah.
It's usually
We're definitely super keen to start playing like a lot more again. Like
Yeah.
we're finally just at that point where, all right, it's time to start presenting what we're doing again.
I'm going to start publishing like a bit of the techniques that I'm doing, like with simple harmonic motion and generative hierarchies and things like that. So I want to start pushing out there. The Jitterbugs, the first Max program I did, I actually presented at NIME at the end of my honours. So that was good to kind of see where people are at.
Yeah.
But then I kind of just retreated into my own world for a long time just to try and get this stuff ready. And now that I've got these things that I know work really well and they can kind of spawn into different areas, I'm going to start publishing research and getting out there a bit more. But yeah, I mean, I guess what we want to do is just kind of get out there and meet promoters that gives us $200,000, not for us,
And laser beams.
just so that we can hire equipment to do these shows because they require so much equipment to create this like ineffable, like what the hell experience. It's just.
Are there any local theatres or spaces that have some of it already set up so you could hire this? You don't have to hire the gear, you can hire the space for.
I think.
I'm sure there is. I was speaking to.
Yeah, we've got a couple sort of people
yeah.
on the pulse for us.
Yeah, we've got a few people that are kind of high up there that
Yeah.
reckon that they can let us play with 60-watt laser beams.
Yeah, I think is it Mutech that's going to be back?
Yeah,
Be
Mutech's
here
coming out
year.
next year, so we'll be playing at Mutech in November, and yeah, slowly getting out there.
Yeah.
Cool.
Okay.
Well, thanks,
Yeah.
Gabe.
Yeah, thanks
thank
for
you.
coming and listening
Cheers.
to us.
Thanks.